The refrigerator that uses the least power is the one that's completely turned off. Today we're going to look at how I managed to get my boat's refrigerator, with outside temperatures above 30 degrees, to run only 13% of the time. My fridge spends 47 minutes resting for every 7 minutes of work. I'd very gladly sign up to live like that. So today we're going to save more than 250 watt-hours of energy each day by optimizing how the onboard fridge operates using some very simple tricks and tips.
Man, summertime, the fridge, enough with all this sailing and all this crap. Finally, some actually useful stuff.
Do you know what it would be like to work 13% of your time? Work 3.5 hours a day, and that's it. But every day.
Then to the fridge to grab something.
And then you can simply go and live that crazy life.
I'll take you up on that.
Greetings sailors, and welcome to another new episode of The Low Cost Sailor. In today's episode, we're returning to the topic of onboard refrigerators. We're going to walk through every step from how to turn almost any cooler or cabinet into a refrigerator by simply adding a compressor and an evaporator with no need for prior knowledge, tools, or any special skills, all the way up to how to get our refrigerator to its best possible energy efficiency performance point. We're going to significantly improve its overall power consumption and give our batteries a well-deserved break. They'll look much more favorably on having a 12-volt fridge running on board, since batteries really don't like that very much. And we're going to go through all of this with the help of SVB, who, with their more than 30,000 marine items from 350 different brands, has sent us all the material needed to make this video. The thing is, with SVB, it's always very straightforward because they ship really quickly to almost any port in the world. Also, SVB is no longer just an online store, but rather a real little community of sailors, thanks to things like My Boat, where you can find and also help others find the spare parts and materials that have worked best for your specific boat model. Around your boat, you have the Owners Club, where you can talk and exchange opinions, ask for advice, help and suggestions from other owners from anywhere in the world, with no language barriers at all, because SVB makes sure you can all understand each other clearly. I'm using it extensively in many of my projects, and honestly, it's a pleasure to meet other boat owners with experience on your same boat model.
So that's where you get the ideas from, buddy, and then you go around saying it was my idea, it was my idea?
No, that's where I get things from. How thick is the rigging on your boat to see if it's the same as mine? Has anyone gone up there so I don't have to go up myself? Has anyone gone up there and can send me a photo of the connectors? And do they send them to you? Yes, it works. For me, the fridge is one of the accessories that brings the most joy on board a boat. Well, for me and for Carlos.
I agree.
And I'm not saying it only because of the sheer number of cold beers my guests can drink, but because it truly allows me to eat on board almost every day, keep my food properly refrigerated, take my little getaways, and, let's be honest, enjoy a hot summer day at anchor with my food and my drinks genuinely nice and cold. But I know my boat's batteries didn't feel exactly the same way. They've always looked at the fridge with a certain amount of suspicion, and not without very good reason. One of them has had to endure the truly enormous power demand from a badly configured fridge right up to the point of failure. And I have to say that, in spite of everything, I was happy with my fridge, but only because I had little information. My eyes started to open in our episode 82 when I began to put numbers to what was going on in it thanks to the digital thermostat, and to see the problems my compressor was having with moisture. There we took a detailed look at how a refrigerator works, how to deal with its main problems, and we even learned how to change its refrigerant gas. For a while it kept serving me, until it got to the point where I couldn't repair it anymore without desoldering the tubes and doing work that might be too complex for me. As a final touch, I decided to replace the compressor and evaporator assembly in a surprisingly simple way, as we'll see later on. And the thing is, my refrigerator is an extremely important component on my boat because it's running 365 days a year, since, like most days on board, its performance went relatively unnoticed because the boat was always connected to shore power at the marina when we weren't sailing. But of course, when you're anchored or when you decide to completely disconnect from the dock's electricity, like I did a month ago, you start to realize the real energy cost of having a refrigerator on board to save myself 25 euros a month, even more so if you're a data nut. And like me, you have everything monitored with the Raspberry Pi. I started by fully monitoring the state of charge of my batteries and solar panels to see whether I could afford to stay disconnected all the time. But in addition to that, I installed several temperature probes in the fridge that allowed me to see in great detail what was going on inside it, and then that's when it all really clicked for me. The fact that the fridge is the item that consumes the most energy on a boat, or even in a motorhome or a camper van, is not a myth. It's a real, everyday reality. It's the item that runs 24 hours a day and can have a power draw of roughly 45 watts. around 3.5 amp hours, which means that over a full 24-hour day you could potentially end up draining roughly 84 amp hours from our batteries. That's almost 1 kilowatt hour. And all of this while talking about the Danfoss BD35F, which is one of the most popular compressors on the market and one of the most efficient. But don't worry, because it's not that dramatic. Our fridge really shouldn't be running constantly. If we analyze the temperature inside the fridge, we can clearly see that its operation alternates between run cycles, during which the evaporator cools down to sub-freezing temperatures to draw heat out from the interior, and rest cycles, during which the fridge gradually warms back up due to the outside temperature or from opening the door. Of course, these cycles are automatically regulated by the thermostat. The power and overall efficiency of our compressor will basically determine how long the on cycles actually last, while the insulation quality, the outside temperature, and the thermal inertia of whatever is inside our fridge will determine how long the off cycles last. Around this topic, there are a few myths and everyday habits that can seriously undermine the overall performance of our setup. For example, the most classic one of all, opening the fridge very frequently or leaving it open for a long period of time. The typical mom comment, "Close the fridge, you're letting the cold out." Well, what do you want me to tell you? When has a mother ever been wrong? One of the most common ways to reduce our fridge's overall performance is to open it too often or just leave it open. This is a little less noticeable in the more classic top opening fridges on boats like mine, because cold air is heavier than warm air and therefore tends to stay down below. But with side opening refrigerators, the kind you typically have in your homes, this is definitely something you really need to keep in mind.
You say it's mothers? For me, my wife is the one who picks up on this. If I open the fridge even a microsecond longer than necessary, you can already hear about it around the house.
Another very common habit, and let the one who hasn't ever done it throw the first stone, is turning off the fridge at night. This adds up to two problems. The first issue is the food safety risk. If the only thing you have in the fridge is just drinks you want to keep cold, I understand. But if you have milk, other perishable foods, and that kind of thing, the inside of the fridge can fairly quickly reach temperatures above 7 or 8 degrees, and bacteria will start reproducing like crazy. But on top of that, you'll have to recover all that lost temperature in the morning, and you'll end up turning it on first thing when there still isn't enough sun yet to have an energy surplus on your solar panels, for example. The reality is that it's much more efficient to slightly increase the thermostat temperature and keep the temperature the refrigerator reaches properly under control. Surely, if you find yourself forced to turn it off at night, like what used to happen to me, and I'm telling you, I've personally done it myself, it's because your batteries can keep the fridge running throughout the whole night until dawn. And your problem isn't the fridge. Your problem is that your batteries aren't in good condition or aren't properly sized. But without a doubt, what takes the most effort and uses the most energy in a fridge is pulling the heat out of hot food. And by hot, let's simply mean things that are sitting at room temperature. I saw it myself just the other day, when I filled the fridge with drinks and food that I just bought from the supermarket, and the fridge's cooling cycle quickly multiplied by 5, and it took the compressor motor several hours of continuous running to get back down to its set temperature. This doesn't mean you can't add things to the fridge, but try to make sure that when you put in new groceries, it's during times of energy surplus during the day, when your solar panels are generating at full capacity, when you're plugged into shore power, or when you have the boat's engine running. And even though it may seem a bit counterintuitive, a fridge that's full of cold items is actually more efficient than a fridge that's only half empty. This is because you're adding more thermal inertia to it. Those things that are already cold tend to warm up more slowly than the air does, so they help extend the compressor off cycle. So now you know, it's better to have a fridge full of drinks than a half empty one, and that's always true for many good reasons. Also, adding ice packs inside the fridge or placing them right next to the evaporator coils can help quite a lot in increasing that thermal inertia, but they don't bring nearly as much joy as drinks do.
And speaking of joys, please take a moment to thank our Patreons, because they give us a really whole lot of joy.
The ones who truly make us happy are our sponsors and our Patreons, who will appear right here on the screen, who are supporting us month after month so we can keep making these videos, and without them, what would we do? Take to drinking. In order to improve our refrigerator's performance and apply all these good practices we've seen, the first thing is to have a refrigerator. And there came a time when I stopped having one when my old compressor finally died. When summer suddenly arrived and the fridge stopped working again, this time already showing signs of a leak somewhere with the evaporator rusted and badly pitted, it was time to replace it, and I was in a bit of a hurry. And when I'm in a hurry and I need something quick that works, SVB never lets me down. The fastest answer, and even the cheapest, could have been to add a portable cooler to the boat, as we saw in episode 58, like the one Carlos has on the Trastolillo, or with some of the options we have in SVB's catalog. For less than 300 euros we can get a portable compressor cooler. But the reality is that if there's one thing that's truly expensive on a boat, it's space. Looking for a place to fit in a portable fridge when I already had a space designed specifically for it would have meant wasting quite a bit of valuable space. Even if I didn't have that compartment, I'd seriously consider repurposing some locker by adding really good insulation to the walls, along with the compressor and the evaporator, and then I'd have a fridge without actually taking up any extra space. A new compressor and a new evaporator were just what I needed to restore my fridge to all its former glory. Even though there's an endless number of refrigeration kits in SVB's catalog, the decision is quite easy to make. Basically, almost all compressors are based on the two most popular ones in the world, which are the Danfoss BD35F and the BD50F. The BD50F is between 25 and 45% more powerful than the BD35F, but the BD35F is the most popular. And for refrigerators up to 130, 150 liters, or even freezers up to 60 liters, it is a super effective solution. The only exception is if you do tropical cruising or have larger volume refrigerators, in which case my recommendation is the BD50F. The rest of the decision is choosing the right evaporator, and there is indeed a huge variety there. The first rule when choosing the evaporator is that it fits and is compatible with your compressor. SVB shows you a page of compatibility charts. The second criterion is the format. The most efficient ones are the vertical plates that cover a good portion of the fridge's height, but there are also ones shaped like a rectangular box whose main selling point is that they allow you to use that interior area as a freezer. Basically so you can have ice cubes. Who doesn't want some ice cubes on board? The swap was actually very simple. In the compartment of my old fridge, which was already very well insulated and taking advantage of the location under the chart table where the previous compressor was installed, I decided to install the new one right there. The old one, with its leak, no longer had any gas left, so taking it out was fairly simple, since it uses quick connectors between the compressor and the evaporator. The new unit arrived really quickly, and everything came perfectly well packed as always. And you already know that if you use the code TheLowCostSailor on your purchases at SVB, they'll include a gift with your order. The cap that we like so much. Now you can choose, and there are alternatives. You can choose your own gift. The new kit that I chose already came equipped with a Vitrifrigo ND35, which even includes a tray to collect frost, although I haven't used it because my fridge has a drain. For around 529 euros, it's definitely one of the most affordable options that comes with a box evaporator. The evaporator even comes with 2.3 meters of insulated piping, which allows for a fairly good distance between the fridge and the compressor if that's necessary. Since the size was almost identical to the previous one, I used the bracket I already had on the top of the fridge to secure the new evaporator and followed the exit route through the hole the chest already had. Through this hole, the thermostat's temperature probes will also need to pass through. In my case, I'm running several probes, and the kit comes from the factory with a mechanical thermostat, but I set it aside because I already had an electronic controller ready to use from last time. By the way, here's something that's kind of curious about mechanical thermostats. Do you know what the numbers on the dial are actually supposed to mean?
Well, the degrees you want to set it to, right?
Well, those numbers aren't the degrees you want to set the fridge to, they're the level of cold intensity. Again, 1 is the lowest level, the one that cools the least, and the higher the number, the greater the cold intensity, to the point that it could even turn the fridge into a freezer. But of course you never really have a clear idea of what the fridge's actual temperature is, which is why I use digital thermostats. So, once the evaporator is installed, you just need to find a well-ventilated spot less than 2 meters from the fridge to place the compressor so it won't be in the way. The compressor comes with its own fan for the condenser, but even so, the area needs to be well ventilated. If it isn't, you'll notice that it takes the fridge a very long time to lower the temperature. The next step is simply to connect the evaporator's quick connectors to the compressors. They're color-coded, so you can easily plug each one into its corresponding spot. You really can't mess it up, they're very easy to screw on and tighten securely without any gas loss. In fact, the built-in valves don't actually open until you've fully tightened both connectors. You can do this yourselves with a couple of open-end wrenches. It's a super flexible, easy-to-use solution without having to think about the gas, without having to do anything. The only downside is that you can't really shorten the length of the tubes that run from the evaporator to the compressor. So if you end up with any extra length, what you need to do is simply coil it up and store it neatly right next to the compressor. compressor. And that's basically it. Now all that's left are the electrical connections, where we have three main things to connect. At the very top of the compressor we have the 12-volt power supply, which will typically run to our switch panel through a fuse or a circuit breaker. Down below we find the fan connection, terminal F. That's the point where the motor's built-in fan is connected, and you can also connect additional fans, as we'll see a little later on. There is an additional connector in case we want to install an indicator LED that flashes, for example, if there is a fault, or to tell us when the compressor is running. But I can tell you that in these fridges, unless you hide the compressor very well, it's easy to know if it's on by the noise. Finally, there's the thermostat connector. These compressors can operate at several different RPMs and power levels, depending on what's actually needed at the time. They come with a small adapter resistor that allows us to select the RPM. We'll connect the thermostat between connector C and the connector for whatever speed we want. The lower the RPM, the lower the instant power consumption. But if you're going to use it as a freezer or in warm climates, you may want to squeeze out the maximum power with the options of 2000 RPM, 2500, 3000 or 3300. I currently have it set to 2500, but on especially hot days you may need to give it a little more extra power. Finally, there are two additional connectors that regulate the low battery protection level. If you make a direct jumper between the two connectors, the safety system will change. The threshold will let it drain the battery even further before the fridge finally shuts itself off. Something I really don't recommend at all, because if I've already told you that coolers are true battery vampires, just imagine what happens if you try to squeeze it even more. And that's it. You'll now have a new fridge up and running, ready to keep all your drinks nice and cold. Well, drinks, food, whatever each of you wants to put in there.
Drinks, just drinks.
We finally got to the energy efficiency improvement section. Since I have a lot of data from my refrigerator, I already had a clear idea of what my starting point was. Also, with the latest heat wave, I had a fabulous testing environment. In my case, I was already starting from a pretty good operating state, with an accelerated level of efficiency. But there are always possibilities to improve. My starting point was, with it being 30 degrees outside, to keep a steady, stable temperature between 3 and 5 degrees. In the fridge, I had a cycle of about 11 minutes with the compressor running for roughly every 35 minutes of rest. In other words, the motor was running approximately 31% of the time. It was not going to be particularly easy to improve it, but making the attempt would at least help us carefully review the fridge's weak points. The very first step was to check the insulation. The thicker the insulation is, the less cold it will end up losing. As a general rule, for a conventional fridge, about 5 cm of insulation thickness is recommended, and roughly double that if it's a freezer. But this insulation might not be perfectly uniform everywhere, and its weaker points can often be the lid and the seals. Taking advantage of my phone's thermal camera, I gave my fridge a thorough checkup and found a weak point in the sealing gasket, which I replaced and reinforced, especially around the hinges. I also fixed another commonly overlooked point, the drain. Since my cooler was originally an ice chest, it has a drain at the bottom, and around the pipe there was a total lack of insulation. The gap was pretty huge, so I made up for it by applying an extra layer of K-Flex, using what I still had left over from the onboard insulation incident.
You fix everything with K-Flex, between the K-Flex and the vinyl?
With K-Flex and vinyl, you could practically build a house. Grab some street cardboard boxes, wrap them in K-Flex, then cover them with vinyl, and you've got a gorgeous house. Another very common problem my system was dealing with was ice buildup on the evaporator. That ultimately stemmed from a mistaken assumption. I was actually using my thermostat probe the wrong way. I was measuring the air temperature inside the fridge and setting it to the exact degrees I wanted for the food. This is very effective, but it's also quite inefficient. Measuring the air temperature introduces a noticeable delay compared to the evaporator's real immediate temperature, and it can also cause the evaporator to never warm up above the freezing point between cycles, increasing the amount of frost that so greatly reduces heat transfer. Manufacturers typically recommend measuring the temperature directly on the evaporator, with the probe firmly attached to it. In my case, I secured it in place using heavy-duty aluminum tape and kept it as far away as possible from the point where the gas tubes enter. This makes the value you select on the thermostat no longer the final temperature of the fridge, so you have to play around with the numbers. After several tests, I gave all the information from all the results to an artificial intelligence, and it calculated that the ideal cutoff temperature for my thermostat, in my case, was minus 14 degrees for shutting off and 5 degrees for turning on, and that's how I set it up. This adjustment significantly boosted the fridge's overall efficiency, bringing it down to under 20% of the compressor's total running time. However, the temperatures inside the chest were no longer completely uniform. The probe I had mounted on the side of the opposite wall started showing readings between 7 and 8 degrees, which was already putting me just a bit into the food safety risk zone. But the problem wasn't a lack of cooling power from the fridge, but rather how the cold was distributed inside it. When it's packed full of food, thermal inertia is improved, but at the same time, and especially in these top opening chest fridges, the natural circulation of air gets blocked and the cold wasn't distributed evenly throughout the entire fridge. I found the final answer by installing a small internal 12-volt computer fan, 4x4 centimeters, positioned so that it pushes the air from inside the refrigerator directly into the interior of the horizontal evaporator, creating circulation and consuming only an insignificant 0.05 amps, which has allowed me to blow the previous numbers out of the water. Thanks to the airflow, I've been able to raise the thermostat shutoff temperature, leaving it between a minimum of minus 11 degrees and a maximum of 3.5 degrees. With this approach, I've managed to get the fridge's actual temperature to fluctuate really nicely and evenly between 2 and 5 degrees. And best of all, it's something that shows up truly spectacularly and clearly in the graphs. Now the compressor runs in consistent cycles of only 7 minutes of operation for every 47 minutes of waiting time. In other words, my fridge only really needs to be running about 13% of the time, even with an ambient temperature of 30 degrees in the boat's living room. A complete success.
And all just to save yourself the $20 a month to plug in the boat.
25. If it were 20, I'd think about it. No, because now I have to save.